So just to prove the theory that it's a control side issue and the whole thing is shutting down power, here's the power feed to the ignition coil. Hopefully you guys can see that in this sunlight. Okay, so you start it up. So it just cuts power to the ignition coil, cuts power to everything actually. So it's a main relay, you know, whatever controls that, that's where we're going to focus our search. Alright, PR1, that's what feeds our ignition coil, which is losing power after 3 seconds of running. Fuse is fine, that would not restore itself. So PR1, this is the load side. Now for the control side, we have to look at all these sensors and switches, and there's PR1 right there. It says OP coil. I assume that means oil pressure coil. Now, for this thing to activate, we need power and ground. And to get power to here, it looks like kind of a, I don't know, funky, several things have to happen. CR3, then there's this guy, TR3. So this is where it gets a little complicated because several things have to happen for the power to stay on, you know, right here. So I'm just trying to kind of think this through. This is what I had to do on that diesel as well. So there's definitely like a safety. So it's not happy with something, so it's shutting off PR1, which is right here. So you have to figure out why. A piece of tack. Okay. So we just want to see which relay is which on this relay board. And we're worried about PR1, this oil pressure relay. And up here, this guy is the key player. So let's check the load side, see the fat wires, that's the load side, and then this is the control side. So all we need is a test light, and what we can do is, well, first test light the battery negative. This should be our constant power feed, and it is. And then this guy should get powered on when it's running, and see what happens when it shuts off. So crank it. You actually heard you can feel the relay like click. So it shuts off. Why does it shut off? Now let's go for the control side. According to our diagram, which was here, the control side on PR1, one side is constantly grounded, the other side is, you know, either a power feed, or when it loses the power feed, then the relay shuts off. Okay, so again, test light to now battery positive. So that looks like a good ground right now. Let's start it. So it stays a good ground. That's our ground side. Now what happens on this control side? Let's see. I'm going to go test light to battery negative now. So this should light up to power on this relay. Ready? Boom. When we lose the power feed on this control side wire, the engine shuts off. Now, can we do a little bypass test, keep this relay powered up just with a test light, and see if this thing will stay running? So now test light to battery positive. Good. Our test light works. So it's not enough to click the relay right now, but it might be enough to keep it on. So let's turn it off. So my test light's keeping on. So that proves that it's a control side issue on this PR1 relay, like we thought. So now the question is, what on the control side? We're losing the power right here, so it could either be CR3 shutting off, it could be this timer relay, I guess, turning off. This should be closed, normally closed. Okay, so CR3, we have to look up what that is. And that is controlled by, oh geez, you can go to oil pressure switch, you can go to water temp switch, you can go to, well, that's supposed to be normally open, loose cable unit. That's interesting. Don't know what that is. But this CR3, you know, if that clicks on and we lose the, how do we determine if it's this guy or this guy? Let's think about that. Well, Vladimir here did the old school tug test because we're worried about the control, you know, feed to this PR1 relay, and doing a little visual inspection. What is this supposed to be connected to? There's a diode here, and apparently there used to be some kind of relay on this side, and then this wire is tied in, and that goes nowhere as well. So that's one of the feeds. There's actually three wires that come into here. I guess we can kind of trace them, but not really. I mean, there's a whole bunch of stuff that's just been hacked and disconnected. This is where the time-consuming part is. I mean, I think one of the technicians said there was like a dirty freaking signal on the beacon lights, and they disconnected the beacon lights. I'm like, yeah, that makes sense. So let's try to locate CR3. It should be actually right in this panel. So let's undo these two bolts and see if we can find it in there. Okay then. We have a whole bunch of stuff here behind the control panel. These are the gauges, and right in here should be our fuses and relays. Now let's look at the computer screen again. So CR3 oil pressure, so there's two diode blocks, and then 1, 2, 3 going right here, this guy, and then I don't know what this guy is. Might take a little while. So let's find where this timer relay is. Where's the timer relay? T. Timer relay. T. There it is. Start delay timer. TR2. That should be. Is it this guy right here? This thing is so hacked. Alright, so we're chasing this control issue for the PR1 solenoid, which on the wiring diagram is this guy. And it feeds pretty much everything. Here's the main fuse, and it just branches off and feeds you know, our ignition coil. So why is this PR1 solenoid control side? Obviously the ground is good. Why are we losing the feed to the control side of PR1? Well, we have to look at CR3. This switch right here, it's a relay. There's control and load. And then the timer relay. Well, the timer we know works because for a while this thing runs, and then the timer switches off and it actually shuts off. So the question is, are we missing the feed through CR3? Now CR3 is the relay right here, and you know, so we'll plug it in and just focus in on the contacts here. We can actually see the contacts do their thing. So 1, 2, 3. This guy right here, let's take a close look at what they do. So key on and then crank it. Was that normal operation or not? Let's try again. So crank it. So you saw when the engine ran, the relay was, the contacts were open, but then everything just shut down. Like the contacts closed and the engine shut off at the same time. So it's not like it was cause and effect, you know, CR3, you know, opened the contact and then the vehicle shut down. This whole feed we lost. So to rule out this relay, what we want to do is basically bypass, you know, start the engine and then just jumper from here to here through a test light and see if the engine stays running. That will at least verify wiring integrity from here all the way to PR1 and verify the feed, and you know, we have to check the relay that way because visually it seems to be working just fine. So let's plug in our little trusty test light, and it goes from terminal 9, which is here, to terminal 1. So remember, this is the normal position, and then when we start it, it goes, you know, it jumps down here. So it's actually connecting 5 and 9 when it's running. Is that right?
When timer relay is running, it
connects
okay. 5 and 9. And when timer relay shuts, it connects 9 and 1. It's the run position.
So normally running, right, this thing should be closed, correct?
Correct.
When we're running.
9 to 1.
Okay. 9 to 1 when it's normally running.
Yep.
And 9 is our feed from the white wires down here. And 1 should be coming up to our brown wires, which go to the PR1 control side. So basically we're going to start it up and connect 9 and 1 and see if it stays running, okay? So start it up. So what does that mean? On the relay, when it's plugged in, 9 and 1, when it's running, should be connected. So that little tab should go up. Is that correct?
Correct.
Does it go up?
Yep.
Okay, let's try again. No, it never went up.
Okay, let's try again.
So what? Okay, let's try again. It never went up to here. Okay. Now,
from my point of view, it did.
Well, only when it shut off, right? It didn't go up first.
When that shut off, correct?
Yeah. So I'm saying we lost the feed. We can even prove that. Well, it's kind of a closed loop. Let's see if we're losing the feed up here, you know, when that happens. Boom. And the contacts never moved, right? Well, I mean, if we lose the power feed, then the contacts will switch, but when we bypassed, you know, from 1 to 9, it stayed running. So now the question is it a control side issue for CR3? And what controls CR3? This is taking a lot longer than we planned. We're almost deaf because the thing backfired and almost blew apart the muffler. So we got some of these now because we don't want that to happen again. Now, okay, so CR3, this relay right here, we already found, okay, so back up a little bit. It's not a relay fault. The wiring integrity from here to PR1 is good. We verified that using the bypass test. When we connect terminals 1 and 9, the tractor stays running. Okay, great. So it's a control side problem. So on the control side, let's look at the diagram really briefly. On the control side of CR3, we have a power feed. And what controls it? We have this loose cable limit that's normally open. We have an oil pressure switch that's normally closed, but when you start the engine, it opens. And a water temperature switch that is normally open, and when it gets too hot, it closes. Okay, so when this thing is running, that's open, that's open, that's open. So CR3 is not energized, so it should stay closed. If something goes wrong, this guy turns on, and we lose the feed to the control side of PR1. So wrap your head around that. Now, as we saw by the contacts on CR3, it was, you know, you start the engine, the contacts change position, and then the oil pressure, you know, builds up, the light goes out, but the contacts never come back. So there's no feed to PR1 through CR3, so it's a control side issue. Now, which one of these three legs is the culprit? Well, our oil pressure switch, we don't believe is the culprit because, you know, the little light turns, you know, first it's lit up, so we have a good ground here, and then it goes off as the oil pressure rises, so that closes, and that opens, light goes out, everyone's happy. So we don't suspect that leg. We have two more. This normally open wire, there's three wires here, okay? We don't know which one's which, but this guy was connected right to here, and we just started disconnecting them. So that's one, and no matter what, this guy stays a ground, and that is bad because that would keep the relay turned on, which we don't want. We can prove that. Test light to battery positive, good ground. So this green wire, if we start up the tractor with earmuffs, watch out. So that stayed bright. That is a constant ground. So I don't know where this goes. We're going to unhook that. Now we have two more wires here, okay? Again, let's go in here. Test light's bright. And as we start the tractor, here, I'll help Vladimir start. Go ahead. That goes out. Let's get running. Okay, let's try that again. So, right now, key on, oil pressure light's on, right? Test light's on. Because our switch is grounding both this and the relay. As we start it, this should go out at the same time as the light. So let's see if that happens. And it stays running. So it stays running. We fixed the problem. This green wire right here was just constantly grounding that relay. I mean, I don't know, I think it goes to that loose cable limit switch, which has probably been disabled several times over. Again, we just want to get this thing running, and, you know, time constraints, people, time constraints. Anyways, let's just do another final check, make sure everything works, and we should be good. Okay, go ahead.
Uh-oh.
What the heck? Wait, let's try again. Okay, go ahead. Are you kidding me? We just proved that it worked.
No way.
Wait, okay, let's do the test light thing again. Test light to battery positive on this relay. So which wire is this? This is the power feed to CR3, and these are the two remaining, you know, oil pressure switch and whatever, water temp control wires. So that's a ground, and we see correlation as we start this thing. The oil pressure light and the test light go off at the same time. So check it out. Yep. So what happened there? Let's take a look at the relay. What are we losing? Oh, it sucks when things change during the diagnosis. So, again, it's all about the control side of this CR3 relay, right? And just a second ago, when you put your test light from battery positive to here, what the? Well, this should light up because the engine's not running and we have no oil pressure, so the oil pressure switch should be closed and the current should flow right through there. It does not. And look what changed. Now, our oil pressure switch does not work. That's nuts. I mean, that's a variable. If you measure the voltage on this pin, right now it's 10.4. And it should be 0. So the oil pressure switch right now is just like stuck wide open, and this thing should start and run with our earmuffs on. Cheers. Check this down. So let's hold this on here. Voltmeter. So we have 10.8 volts. Let's start it up. Uh-oh. Nothing? And what's the voltage on here right now? 10.5. So if you take the relay out, can you start it now? It'll die. So this relay needs to be in there. It needs to be in one position to start. Oil pressure builds, switches it, and keeps it running. So if it's in and the oil pressure switch is showing, you know, it's not grounding this leg at all, the relay is in the, should it be in the down position then? Here, turn the key on and off. Okay, on. And, okay, that's, is it on right now?
Yep.
Why are we only at 2 millivolts? Is the oil pressure switch or light on? No, it's not. Oh, okay, yeah, there's no feed. Okay, go ahead, crank it. It'll stay running.
I turned it off.
But why was it not starting just a second ago? So with that alarm on...
I think it's backfeeding some through.
Are you kidding?
Meter. Enough.
Oh,
enough for it to start.
No way. I can't believe.
It's like 1 mega.
But again, Vladimir has already proven me wrong on a couple of things here. Let's see.
No.
Nothing.
No,
okay.
It's not enough.
So what do we have to do?
Unplug and plug it back when it starts.
Wait, so... But you can't start it without the relay?
Yep. You need
wait. So with the relay, you turn the key on.
It's on.
And it won't crank right now. See, why did it crank? This thing's so freaking consistent. Anyways, the oil pressure switch seems to be funky because we lost this and now it stays running. It's either not fully grounding or fully letting go of the internal contact. So I think we should get to the oil pressure switch, unplug it, see if our wiring integrity is good, and then just tell them to replace the oil pressure switch. So we're looking for this oil pressure switch. That red wire that we pierced, that was not the oil pressure switch. That was the coolant overheating switch, apparently. The oil pressure switch is actually a mechanical line that goes to this gauge, and then we're looking at this thing. I'm like, well, there's some backlighting wires, and then what the heck is this? And easy way to check, will our oil pressure light come on with the key on when we ground this guy out? So I'm just going to ground it on the little bolt here. There it is, okay? So theoretically, with this grounded, this thing should be happy, it should start up, and then I'm just going to take it off like we have oil pressure and see if this thing runs, okay? Alright, bypass test. I'm going to hold the wire on here. Actually, we should just probably ground it to something. Is that ground?
Yep.
So I'm just going to shove it in. Well, let's see. Need good contact. Is it on?
Yep.
Okay. Battery's about to die. Let's start it up. What the heck happened? Damn it, I need to charge my camera. Okay, this is when it gets hardcore. So, putting all of the pieces of the puzzle together. The main problem with this relay is that we have voltage here when the tractor is running. And what is the voltage? It's 10.5 volts. So we have on the feed to the relay, we have, battery voltage is like 14, and this is 10.5. And that 4 volts is enough to keep the relay from going into its normal run state. That's how sensitive these things are. 4 volts across, and it will not switch when it's supposed to. Now the question is, why is there only 10.5 volts here? When, on the wiring diagram, when everything's open, water switch, oil pressure switch, this like wire brake switch, when these are all open, we should have battery voltage on this side of C3 right here, and we don't. We have 10.5. Why? The other clue is this water light, warning light, is actually dim when the key is on, and when the truck is running, it's also pretty dim. So we put our heads together and we think that there's a ground, a partial ground, not a full ground, partial ground somewhere in this leg of the water temp switch circuit. Okay, and that's actually keeping this relay energized. Very small current going through this diode, and it's keeping this relay energized, and that's why the tractor is shutting off. What we want to do is, at this junction, just remove this part of, just basically, it's the same thing as cutting this wire right here. Boom. So everything will work, oil pressure, that will work. The only thing that won't work is if the thing gets too high, it won't shut itself off. Because looking for a ground in this leg, it could also be somewhere in the boom. And we're just not going there tonight because this thing is already hacked, to hell. So, anyways, let's undo this spot, and conveniently, it's located right here. So 29, this wire right here, if you tug on it, it actually goes right to our C3 relay. It's this guy right here, C3 relay. So we're just gonna unhook it from here and see if this thing runs. So, measuring voltage on this little guy here. First, let's just put in the diode like it was before. Let's see what happens right here with the key on. See how dim that is? That's a partial ground. And let's go ahead and crank it. 10 volts right there. And it's supposed to be battery voltage. So now, let's unhook this guy, take it out of the picture, and do the same thing. See what the voltage is. Yes. Now it should stay running. Woo! A little rich. That's still dim. Short to ground. Like that. Fantastic. Alright. I think we got it. We're going to leave this unplugged so the water temperature safety thing won't work. We're not chasing a partial short to ground at almost 10 p.m. when we still have to drive. And yeah, I mean, this is crazy twisted diagnosis. We had broken wires, we had voltage drop on the relay, partial ground there. Our spark plugs are fouled. We had to clean those out to get this thing running.
Clogged fuel.
Yeah, there's no fuel feed from the gas tank. There's just, it's just hacked, but now it runs. Now the last part, the customer's original complaint before any of this crap happened was this governor. And let's just check how this little guy, the box, controls on this control wire, what it does when we raise and lower the RPMs. And if this box works, then the only thing we're worried about is this, the mechanical, whatever, electrical, solenoid or whatever that actually pulls on the throttle. So just 10 more minutes here and we'll have this thing wrapped up. Okay, last step, the governor. We're going to check it with a regular test light, and just briefly looking at the diagram again, it's there's a constant power and it's ground side switched by this electronic governor on pin 4. So if we take a test light from battery positive and touch it to pin 4, and then let's say raise the RPM, the governor is going to be like, oh, calm down, less ground, the test light's going to go dim or off. Once the RPMs drop, then the governor is going to say, oh, we need more RPMs, it's going to ground that pin, and our test light should light brightly. Let's see if that is the way it works. Our test light is ready, it's plugged into battery positive. We're going to touch it on, what was it, pin 4. Just going to stuff it in like Scanner Danner. And let's just do that, and then it's fine. Don't touch it. Stuff it in like Scanner Danner, remember?
No.
Okay, so let's, air muffs.
Safety third.
Yep. Okay. Low RPM, right? High RPM. Low RPM. Raise RPM. So that just proved that the governor box controller is capable of grounding out this control wire. Now, what we need to do is I want to measure the resistance of this box, or we could just straight up run power and ground to here, touch it on ground, watch this thing work, and measure the current going through this box and see if it's excessive. I think that the bypass test will instantly say, is this good or bad? Just to verify wiring integrity from the box to our actual controller, let's do the same test with the test light as we did here. So let's see, test light from battery positive, right? And it should should light on the ground. Okay. Wiring integrity verified. Now let's do a bypass test on this box. Okay, so we're going to re-zero our amp clamp. We're going to put it around a jumper wire that's just connected to ground. So the current's going to go this way, right? And this is going to, I'm going to touch it on the governor control screw. So look at the amperage here. Let's re-zero that again. Okay, 1, 2, 3, full throttle. About 5.4 amps, and then off, then on. So full throttle is 5.4 amps. Is that normal? Well, it doesn't seem that out of the ordinary, and this thing won't be full throttling it all the time, and we know that there's no full ground there, and this wire continuity is good, so I feel confident in hooking this thing up. What do you think, Vladimir?
Oh, it's a hard question.
Hard question.
5.4 amps is still an...
I mean, that's full throttle, 5.4 amps. Is that too much? Because on a test light, with a test light, it worked perfect, right? 150 milliamps.
150 milliamps.
But with 5 amps, we don't know if it's no good or no bad.
Okay. It's protected with a fuse of 15 amps.
True.
Does it have any other power output?
What do you mean, power output?
I mean this servo.
Yeah.
And anything else, or only this servo? Why is
connected to this box?
Yeah. Why is it 15 amp?
15 amp fuse? Well, I mean, they always go higher than the actual load. You know, for your power windows, you have 20 amp fuse for like a 10 amp load.
But if this is the one source, the output source, then it is capable of 15 amp.
So you're saying it should be like 10 amp fuse instead of 15 amp fuse, or what?
I think 5.4 amp.
You never want to operate at the fuse limit because it'll overheat the fuse.
Okay.
You need to at least go twice as high. So again, we don't know if this thing drawing 5 amps is normal, and is that what potentially cooked this box. Now again, potentially, we don't know if the box is actually cooked or not, but this was here for a reason, all right? This was here since the very beginning of ownership, so obviously this was a problem. Why did it burn up? I don't know, but 5 amps, that is, I mean, that's significant for a transistor driver, right?
Yep.
That is pretty significant. If it was like a big switch and a relay, then 5 amps is nothing. But going through a smart box that's expensive, I don't know. But in any case, it starts, it keeps running, and we know the box is good, right?
Yep.
So the only questionable thing is this mechanical governor, and we measured the amperage draw, and it's 5.4 amps.
Correct.
Full, full field. And that's all the information we have right now. So unless we find a known good spec, we don't want to hook this up to the new box right now.
Correct.
Because that's too risky. But I think that's the end of this diagnosis. This Genie is as good as it's going to get. How about that? And yeah. So it's a little late to drive back to Pennsylvania tonight, so I guess we'll figure something else out. And then day, 9 will be tomorrow, right? Alright guys, see ya, have a good night. So a little more story to this. We have a little wire tie right here, green wires, and that's what this permanent ground was here on this relay. And the owner just told us that one of the technicians, for some reason, just twisted those together and bypassed that safety switch. But the only problem is that's supposed to be normally open, not normally twisted together closed. That would definitely be a problem. That would cause a no start, for sure. So this relay would permanently be energized, right? And you know what would happen then? It's if you get a feed, it'll click down. So it would do the same thing. It would kind of start, right, and then stall out.
Yep.
Same thing as having no oil pressure.
Yep.
Same thing. It's like a safety. So, well, good thing we disconnected this here, so we don't need to worry about, you know, undoing that twisty tie. All right. Yeah, just to complete the story.